Assalamualaikum. All right. In this live, I'm going to share a revision on limit, continuity, and definition of derivatives. So we try to do some what we call it as past year for past test questions. All right. So let me just share my screen first. All right. All right. So trying to fix this first. Okay. Let me fix this. Where is the PDF? Okay, looks good. All right, so we have this type of question. All right, so we are asked to find the limits for the first one. All right, so we are given with this type of limit. So what we need to do is to use the what do we call it as so not that squeezing theorem, right? So the squeezing theorem says that, right? So firstly, we'll just recall the squeezing theorem. So squeezing theorem says that if we have limit as x approaching 0 of sine x over x will be equal to 1. All right, so okay, so to solve question 1a, all right, so question 1a, we have that limit as, all right, so let me just pick another color. Okay, we want to find the limit as x approaching 0 of tangent 5x over 6x. Okay, so the strategy is to change the tangent. All right, if you try to substitute the value of x is 0, we'll get 0 over 0 case. So what we need to do is to substitute the tangent. All right, so substitute the tangent into sine over cos, because we know that the identity for tangent is sine over cos. Right, so because it is tangent 5x, so it will become, all right, limit, I'll just write here, all right, because we have not substituted the value of x 0 yet. So tangent 5x will become sine of 5x over sine over cos, TSC, sine. All right, so this is the equivalent to the tangent just now, all right? But we still have the 6x here that we are not doing anything. So I'll just write 1 over 6x because 6x in the denominator, right? So now we have to put this, what do we call, um, sine 5x together with 6x together so that we can use the squeezing theorem. So I'll just write the, all right, suppose we have a limit as x approaching 0. So sine of 5x over 6x, and that cos of 5x will become will be at the other side. All right, so now we are almost there, but now we have 5x here but 6x here. So what the strategy is to bring that one to bring that 6 outside the limit. All right, so we'll bring this 6 outside the limit. So we'll have something like, all right, 1 over 6, right? So that 1 over 6 is that 6 I bring outside. So I'll have a limit as x approaching 0 of sine 5x over x. All right, so for this part, all right, for this part, let me use green color. For this part, I'm gonna use the multiplicate the law for limit, where we also have the, because this is distributive here, all right? So the limit as x approaching 0 of 1 over cos 5x. All right. So now, after calculating this, all right, we note that it is a 5x here, but it is x here. But what we need to do is to make the 5x same as the 5x. So we have to put the 5 here, but we also have to put the 5 here. We cannot simply just put, okay, the 5, I just put there. It's not okay, all right? You have to put, if you put at the denominator, you have to also put the numerator. All right, so now I can still bring this 5 outside here. All right, so this will become 5 over 6. All right, so limit as x approaching 0 of sine 5x over 5x. All right, so for this part, all right, for this part, we try to substitute the value of x with 0. So we'll have something like 1, all right, I multiply with 1 over cos 0. Cos 0 is 1. Bear in mind that cos 0 is 1, so 1 over 1 will be 1, all right? So this side will become 1, okay? So now, for this part, we also get 1 by using squeezing theorem. So our final answer will be 5 over 6 multiplied by 1. We have to show that this part becomes 1. All right, so the and the back at the back there become 1. So our final answer will be 5 over 6, because 5 over 6 multiplied by 1 multiplied by 1 we get 5 over 6. All right, so this is for question A. Let's move to question B. All right, so for question B, we want to calculate the limit as x approaching infinity. All right, so limit as x approaching infinity of the x squared plus 2x over 3x plus 4. All right. So note that for this type of question, we have to divide with the x with the highest power at the denominator. The highest power of x that occurs in the denominator is, in this case, is x. So every term at the numerator and also denominator should be divided by x. So we have something like, all right, limit as x approaching infinity means positive infinity. So everything should be divided by x. So I'll have something like x squared divided by x. 2x must be divided by x also, right? Divided by 3x also divided by x plus 4 must be divided by x. Okay, so now we try to simplify this. We'll have something like limit as x approaching z infinity. X squared over x will get x plus 2, right? 3 plus 4 over x. So now we try to substitute the value of um, x with infinity. So in this case, because we have x here, so this will turn to infinity. So infinity plus 2 will still be infinity. So our final answer will be infinity, because the infinity plus 2 divided by 3 over, divided by 3 plus 0. Okay, so our final answer in this case is infinity. Okay, so that's it for question B. All right, so let's move to question number 2. So we have this type of function. We are defined with this function. All right, so this is the continuity question. All right, so usually for continuity, I'll just write the number line. All right, so for number line, this one for gx is from 3 to 5. All right, so I'll just write 3 here and 5 here. And we note that for less than 3, for the value less than 3, the function that we were going to use is x squared plus 3x minus 18 over x minus 3. For the middle function will be x over 12 plus 11 over 4. And for the one at the back there will be kx over 5 plus 3 over 2. Okay, something like this. So now, determine whether the function is continuous at x is equal to 3. So we recall that continuity. In continuity, we have to check 3 conditions of continuous. All right, so for continuous function, all right. So firstly, it must be defined. All right, if we want to check at x is equal to 3, so we have to check now if g, all right, so g3 must be defined. All right. Secondly, all right, g3 must be defined. Secondly, we have to check limit as x approaching limit as x approaching 3 from left, all right, of gx. And also we have to find the limit as x approaching 3 from right of gx. And if they are equal, so the limit exists. So limit as x approaching 3 of gx must exist. I'll just write the inverted E like this, means exist, right? So next one, we have the condition where the limit as x approaching 3 of gx will be equal to g3 actually. Okay. All right. So firstly, we look at this, right? So we have the part where, all right, I'm going to choose comment here. All right. Or something like that. Okay, nice. We note that we firstly need to find G3. So to find G3, we look at the function where is the 3 is defined, whether it's this function, or this function. So actually it's this function because x is equal to 3 here. All right. So we have to use this function to substitute the value of x as 3. So in this case, we will have something like 3 over 12 plus 11 over 4. All right, so we can perform this using our calculator. So 3 over 12 plus 11 over 4 will have something like 3. All right, so if we get the value, then meaning to say that G3 or Gx is defined. All right, so this is the first condition. Gx is defined where at x is equal to 3 because we get the value here. If we don't get the value, meaning to say like we get infinity, all right? So if we get 0, still defined, right? But if we get infinity, a negative infinity, so it will be undefined there, all right? Undefined. Okay, so now let's proceed to condition number 2. So in condition number 2, we have to find the limit. All right, limit as x approaching 3 from left of gx. So look at your 3 now. All right, your 3 is here at the left of 3, meaning to say that we have to use this function here. All right, the left of 3. So we have to use this function. So limit as x approaching 3 from left of gx will be limit as x approaching 3 from left of x squared plus 3x minus 18 over x minus 3. All right. So we can actually factorize if we try to substitute the value of x3 directly, we'll get 0 over 0 case. We know that if it is 0 over 0 case, we have 3 types of techniques of solving this limit. So the first technique is factorization. So in this case, we have to use the factorization. So when we use the factorization, so we factorize the numerator, we'll have something like x minus 3, x plus 6, if I'm not mistaken. All right, so x minus 3. So we can actually cancel this x minus 3 together with x minus 3. So we are left with the limit as x approaching 3 from left of x plus 6. So 3 plus 6 is actually 9. All right, 3 plus 6 is actually 9. All right. So next one, we can also find the limit as x approaching 3 from right of gx. So we can see that from right of 3, we have to use this function because this is at the right of 3. So x over 12 plus 11 over 14. All right. So we have to find the limit as x approaching 3 from right of x over 12 plus 11 over 14. 11 over 4. So we've tried to substitute the value of x with 3. So 3 over 12 plus 11 over 4. We actually get 3. We see that limit as x approaching 3 from left is 9, but from right is 3. So they are not equal, meaning to say that the limit, right? The limit as x approaching 3 of gx does not exist. Why it does not exist? Because the value of the limit from left is not equal to the value of the limit from right. So it does not exist. So we can directly conclude that, right? Therefore, gx is not continuous, all right, at x is equal to 3. So we don't have to proceed to condition number 3. All right, so this is question number 2. We are done with question number 2. All right. So we net that we try to check first condition and then second condition. But since the second condition is not satisfied, so we don't have to proceed to finding the third condition, right? All right. So let's now proceed to question number 3, right? Sorry. We still have this, what do we call, um, second question. For that one is Roman 1. All right. I'm going to Roman 2 now. We have to find the value of k such that gx is continuous at x is equal to 5. So gx is continuous at x is equal to 5. So we have something like, all right, so at x is equal to 5. All right. It says that gx is continuous at x is equal to 5. So we can use the condition that limit exists. So when limit exists, meaning that limit as x approaching 3 from left of gx is actually equal to limit as x approaching 3 from right of gx. Let me drink first. All right. So now, we have to substitute. I'm sorry. Why is it 3? Because we want to check at 5 now. We know that it is continuous at 5. 5 limits as approaching 5 from left is equal to limit as approaching 5 from right. So look at your function, right? So from left of 5 is actually, all right. So look at your number line. This is your 5. Left of 5 is actually this one. All right. So we have to substitute the limit as approaching 5 from left of x over 12 plus 11 over 4. It's actually equal to limit as approaching 5 from right of gx. So right of 5 is actually this one, kx over 5 plus 3 over 2. Okay, we have this. So we can substitute the value of x with 5. So we have something like 5 over 12 plus 11 over 4 is actually equal to that one is 5x over 4 plus 3 over 2. Sorry, 5x, 5k, all right? Because we substitute the value of x with 5, all right? So we still have that k, so we have 5k. 5k over 5 plus 3 over 2. All right, so I'm going to calculate the one at the left side first. So I'll have something like 5 over 12 plus 11 over 4. This is actually 19 over 6, right? So 19 over 6. This is actually k plus 3 over 2. So to get the value of k, we have to bring 3 to the left side. We'll have something like k is actually 19 over 6 minus 3 over 2. So 19 over 6 minus 3 over 2. So our final answer will be k is actually 5. All right, 5 over 3. So this is our final answer. But please don't put hashtag in my when you're writing your answer, submitting to me. All right. So next one, we are going to find the definition of derivative, right? So for the function, right? Okay, where should I write it? All right, for question number 3, we have to find the derivative of fx. All right, this is the question. This is a function. We have to use the definition of derivative. Fx is actually equal to 1 over a square root of 2x plus 3. Right, I'm gonna maximize this. Right. So we have to use the definition of derivative. So to use the definition of derivative, firstly, when solving this, I would like to find the fx plus h. So we have something like, all right, square root of 2x plus h, all right? X, we substitute the value of x with ax plus h. So I'll have something like 1 over square root of 2x plus 2h plus 3. All right. So now we have to use the definition of derivative. First principle of derivative states that to find the f prime of x, we'll have to find the limit as h approaching of 0 The formula is given by, all right, for because this involves fraction, I'll just write 1 over h of fx plus h minus fx. All right. Okay. So we try to substitute the value of fx plus h and also fx in this case, right? So we'll have something like limit as h approaching 0 of 1 over h, all right? So I'm writing the fraction second one here, all right? So 1 over 2 square root of 2x plus 2h plus 3 minus, all right, and then minus fx is actually given by this function 2x plus 3, right? So now we are going to do the cross multiplication here, right? So we try to cross multiply, right? I'll have something like limit as h approaching of 0, 1 over h. Okay. I'll have a square root of 2x plus 3, okay, minus square root of 2x plus 2h plus 3. Okay, so something like this. So that one will be square root of 2x plus 2h plus 3 square root of 2x plus 3 because we do the cross multiplication. All right, something like this to make the denominator the same now. All right, so we have something like this, right? So now in calculating this we have to try to remove the square root. So to do that we have to multiply with the conjugate. So the conjugate in this case is actually a square root of 2x plus 3 because this minus will become plus now for its conjugate. Square root 2x plus 2h plus 3, right? Everything is, you just copy the same thing, all right? At the numerator and also denominator. Square root of, all right, that one is 2x plus 2h plus 3. Okay, so now we multiply this, right? This multiply with this, and this also multiply with this, right? So have something like, okay, I'm trying to solve this limit as h approaching of 0 of 1 over h. So I'm multiplying this with this, so will give me 2x plus 3, and then we have minus in the middle. All right, next we multiply this with this will give me 2x plus 2h plus 3. Please put in the bracket. So most of the students left this bracket. That's the common mistakes that happen. Right, so everything over. All right, so I'll just copy everything. So I'm going to copy this. Right, so I'll just copy it. Oh, something like, right, square root of 2x plus 2h plus 3, then square root of 2x plus 3, and then I'm going to copy this, put in bracket. Okay, or something like square root of 2x plus 3 plus square root of 2x plus 2h plus 3. Don't expand this, right? All right. So next, we try to simplify the numerator, meaning to say that we have to expand that negative 1 inside. So we'll have something like, all right, limit as h approaching of 0, 1 over h. All right, so I'll have 2x plus 3 minus 2x minus 2h minus 3. So the one at the, what do we call, numerator, I'll just copy this. All right. So how do I copy? Never mind. I'll just write this, right? So don't be lazy, yeah? Right, so plus 3 square root of 2x plus 3. Yes, I know it's kind of annoying, just copy lengthy mathematical sentence like this. All right, so now we try to simplify at the numerator. 2x minus 2x becomes 0. Psh, 3 minus 3 will become 0. Psh. Right, so we are just left with, all right, So limit sh approaching of 0 of 1 over h. All right. So I'll just have negative 2h at the numerator. And again, at the denominator, we have to copy this. Right? Square root of 2x plus 2h plus 3. Square root of 2x plus 3. Right. So we'll have something like square root of 2x plus 3 plus square root of 2x plus 2h plus 3. Close the bracket. Okay. So now, um, we can cancel the h now. All right. That is our intention. All right. So h together with h, we are just left the negative 2. All right. So never mind. I'll just write this. Limit as h approaching of 0 of negative 2 everything over square root of 2x plus 2h plus 3 square root of 2x plus 3. This one put in a bracket, square root of 2x plus 3 plus square root of 2x plus 2h plus 3. All right. So we can now substitute the value of h with 0. And when we substitute the value of h with 0, we note that this part will become 0 and this part will become 0. So we'll have something like no more limit because we already substitute the value of h with 0. So square root of 2x plus 3, square root of 2x plus 3. That one will become square root of 2x plus 3 plus square root of 2x plus 3. Using BODMAS, we have to solve the one in the bracket first. So we'll have something like negative 2 over, that one will become square root of 2x plus 3, then become square because we multiply this together. It becomes square then. And the one inside the bracket, square root of, okay, square root 2x plus 3 plus square root 2x plus 3, we'll get 2 square root of 2x plus 3. Okay. Now, our intention is to, okay, we can cancel these 2 together with 2. So we'll get negative 1, all right? So now we want to multiply square root of 2x plus 3 square with square root of 2x to the power of 1, meaning to say that it is power 1 here. So now we have the negative 1 over square root of 2x plus 3 to the power of 3, because now it is to the power of 2 plus 1. Okay, so that is our final answer. All right. So to check if our question, our answer is correct or not, we try to, find the derivative of this using the technique. All right. So 1/2 square root. All right. So just try to check this. All right. We are given the, let's say y is this square root of 2x plus 3. So just rewrite this as 2x plus 3 to the power of negative 1/2. Okay, so we can factorize this, differentiate this using the bracket technique. We'll bring this negative 1/2 in front, we'll get negative 1/2, and then I'm going to copy everything. So 2x plus 3 to the power of negative 1/2 minus 1. And then we have to differentiate the one inside the bracket, meaning to say that we have to differentiate 2x plus 3. So giving me 2. Because differentiating 2x will get 2, differentiating 3 will get 0. So these 2 with 2 can be cancelled. So we are just left with the negative 1 2x plus 3 to the power of negative 3/2. So this is actually negative 1 over 2x plus 3 to the power of 3/2. So simplifying it, we'll get something like this. So our answer is same now, meaning to say that our working is correct. So that's it for this morning session. All right. So inshallah, if I have extra time this afternoon, I'll go live again and I'll try to solve another set of past tests. Right. So thank you for watching and all the best for your test. Uh-oh.